Hello everyone, welcome to this online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So today, as you are aware, we are doing this we are going through this welding processes. And last class we have discussed welding with consumable electrodes. Today we are going to discuss on this welding with non-consumable electrodes. So whichever the process will come under this category, we are going to discuss in detail. So these three processes in detail we'll discuss in today's lecture. First one will be gas tungsten arc welding, that is GTAW. This is also sometime people used to write TIG welding. So this will be the first one. Then we'll take plasma welding. This is nothing but gas tungsten extension of gas tungsten arc welding. We'll see, and the last one will be thermit welding, which is generally used in railway tracks joining. So one by one we'll discuss. We'll take this. So first we are starting with the gas tungsten arc welding (GTAW). So this is the arc welding. We have already discussed through diagram. It's a simple diagram I'm going to draw, so things will be more clear. So this is the power source, suppose, and through this power source, and one of this part means positive terminal will be connected with the workpiece which we are going to weld. Suppose this is the workpiece, and another part of this source will be connected to this electrode holder. So suppose this is the electrode holder, simply a device used to hold the electrode. So suppose this is the electrode we are holding, and then arc will be generated. So this will be actually the arc, and this is at positive terminal, and this is at negative terminal, this electrode, and current is flowing through this one. Okay, so this is how this circuit is. So we can see here the power source is, then we have connected to this one, this electrode holder, which is holding this electrode. So in this process, in this tungsten, as the name is there, itself is telling, this tungsten is actually non-consumable electrode. Its temperature is very high, so it's approximately 3400 degrees centigrade. So when we are doing the welding, we are creating the arc with the help of this one. Definitely it is not going to melt over there. So if it will not be melted over there, what will happen? There will be no deposition of this over there wherever we are doing the welding. Okay. So this tungsten arc welding, many things are there. We have already discussed in arc welding, other arc welding processes we have discussed. We have already discussed GTAW, gas metal arc welding. In that, electrode was consumable, means continuously it was being deposited, melted and deposited on the area where we were doing the welding. Here it will not be deposited. Beside that, what will be there, as this weld pool is completely open to the atmosphere. Open to the atmosphere means atmospheric air will react with this one, and we know oxygen is also there in atmospheric air. So if it will interact with the oxygen, what will happen? It will form oxide over there. So suppose if I am welding two mild steel pieces, suppose this is the one mild steel piece M1, and this is the another mild steel piece M2. If I'm welding these two pieces, I know iron is there. So if oxygen will react with this one, so oxide will form, iron oxide will form. It may be Fe2O3, or it may be Fe3O4. So anyway, these two are the oxides. So whenever the oxides will form, we know it's a very brittle material. Oxides are very, very brittle. So what will happen? It will bring brittleness in the part where we are doing the weld. So wherever we have to use this part as the application, even a slight vibration over there, it will create a lot of problem, and the chances will be it will fracture over there, or there will be failure of the component over there. So we don't want this one. So how we are protecting our weld bed? So there are two methods already we have discussed. Either we can do with a electrode which is coated. Coated means with flux we'll coated this one, and as this electrode will be melted during the welding, those flux will be on, it will act like a shielding, means it will simply cover just like an umbrella. Suppose we are going in rain, and what we are doing, we are putting umbrella. So what rain is coming, although it is coming and striking, but we will not be wet over there because it is completely shielding our body. Similarly, if electrodes are there and flux will be all over this weld bead areas, what will happen? Although airs are coming, atmospheric air will be there, but it will not be in contact with this. So it will not allow it to react over there. So of course, oxide will not form over there. Another way is we can use different kind of inert gases. Inert gases means that will also act like a cover on the whole weld area where we are doing the welding. It will also not allow atmospheric air to come and interact with this one. So in this process, we use inert gases. Now it may be different type. It may be helium. It may be neon. It may be active gases also like CO2, depending upon the application, what kind of material we are welding, and also what is our requirement. According, we will choose different inert gases to fill this one. So, as I said, we use in this one non-consumable tungsten electrode and shielding gas, that inert gas for the shielding purpose. This is also known as tungsten inert gas welding, TIG welding. Okay, it uses filler wire, optional, in is heated arc and not transferred across the arc. It is optional. We can use separately. We can use a filler wire, but mostly it is not used in this one. Now, as I said at the starting, this tungsten that we use as an electrode in this process, it is having very high melting temperature, approximately 3400 degrees centigrade. So what will happen? It is considered as a good material. Why it is considered a good material? Because melting temperature is very high. So it doesn't matter what kind of material we are going to weld. For example, if we are welding iron or it's well, we know its melting temperature is very high. Very high means it may be up to 1600 degrees centigrade. So if a electrode we are using which is having melting temperature less than this one or even comparable to this one, for example, suppose if it is 1800 degrees centigrade, then there will be problem, because if during the welding a slight change is there or miscalculation is there in the process parameters, welding parameters. So what will happen if the temperature will rise and reach near to this one? So this electrode will start to melt over there. So it will create a lot of problem. So tungsten is a very important electrode which is used because of its high melting temperature. It is 3400 degrees centigrade. So even a material which is having very high melting temperature, easily we can weld by this process. So what is the advantage of this process? Advantage of this process is high quality weld we can produce by this process. Of course, although it is a very costly setup, but as I said, depending upon the application, what material we are going to weld and what is the application of that material, we generally use this process. So why we use this? Because it will produce a very high quality weld. Also, during the welding, no spatter will be there because we are not using any filler over there which will be transferred across the arc. Next is little post weld cleaning because no flux is used. This is also very important to understand, as we are not using any flux here. For shielding, what we are doing, we are using inert gases. So if flux we are not using over there, so what will happen? It will not melt over there. So there is no flux. So after welding, we don't need to clean the part where we have done the welding. Another thing is very important in this process is generally it is used for light metal. Light metal means like aluminum, magnesium, titanium, or copper. These materials are very difficult to weld by the conventional, not conventional mean any other melt based processes. The reason is these are having very high thermal conductivity, as well as another problem with this material is once we will increase the temperature, it will increase the temperature, it will start to oxidize. For example, aluminum, if temperature will be more than 400 degrees centigrade, then what will happen? It will start to oxidize. So if oxidation will start, again brittle oxide will form over there, which will further reduce the strength of the material, or maybe it will create brittleness in the structure wherever we are doing the welding. So whenever it will be used in a particular application, it will create problem. But if we are using this process in reverse polarity means if we are using this one, workpiece at positive and electrode at negative terminal. So this is known as direct polarity. So what will happen at the workpiece? Heat this input will be high. Generally, it comes out two-thirds of the heat total generated by the arc. But if we'll reverse the polarity, means if this will become positive terminal, this electrode, and if this is at negative terminal, then this heat accumulation at the workpiece will be reversed. Reverse means two-thirds will come to the electrode and one-third will come to the workpiece. So in that way, easily we can weld even the material which is very difficult to weld. Next process is plasma arc welding. At the starting itself, I told it is one of the variety of gas tungsten arc welding. Everything is same. Everything is same means here also we need to create the arc as it is arc welding. So we have to create the arc just like this one. Once arc is created, okay, now remaining all the things are same. Means we have created the arc, then we have provision for inert gases to flow in the area wherever we are doing the welding. Suppose this is the area where we are doing the welding. So gases are flowing, everything is same. After that, what we does, gases, generally inert gases, will force through nozzle to pass through that arc at a very high speed. And once it will pass through that arc, it will be ionized over there. And because of their high velocity, further it will increase the temperature, and that temperature may reach up to 17,000 degrees centigrade. This is a very, very high temperature. So that's how actually plasma is generated. Plasma is nothing but ionized gas at very high temperature. So how it works? It is one of the variety of gas tungsten arc welding in which a constricted plasma arc is used for welding. Constricted means it will be passed through a nozzle. Okay, so you can see here different things are there. This is the electrode just like GTAW. So this electrode is actually tungsten electrode. Then plasma gases will allow to pass through this. So this different area has been given through which these things will pass. Then shielding gas will pass from here. Then we can see here this plasma arc and base metal, and generally it is not showing in this. So generally, actually, cooling is also applied. Okay, now so one of the section will be there where will apply a liquid to cool the area. Okay, now so this is the area where arc has been generated. This is the area where arc has been generated. What happens with the help of this tungsten electrode? Will create the arc in this area, and this is actually a nozzle, and then all these things will be joined from the back side. All these things will be joined from the back side. Okay, so shielding gases, whatever the shielding gases we are using, it will come and of course it will shield in this area. But the important thing is once we'll allow the plasma gas, means once we'll allow the gases to pass through this one, it will pass, and as this is a converging nozzle, it's like this one, it is a converging nozzle, so its speed will be very high once it will come out from the nozzle, and this high velocity will gas and strike in this arc area, and further it will be ionized. Ionized means it will be broken in positive and negative ions, and that broken ions or the ions which is having very high temperature is nothing but plasma. So in plasma arc welding, electrode is kept in a nozzle that focuses on a high velocity stream of inert gas. This is very, very important. Everything is same, just like this GTAW. We have created the arc, everything is same. In that arc, what we are doing, through a nozzle, a high velocity stream of inert gases, we are forcing to go inside the arc wherever we have created the arc to form a high velocity, and then it will be broken over there in ions, positive ion and negative ions, and this is nothing but the plasma. So this is plasma, hot plasma arc stream, which is used for both purposes, for cutting purposes as well as for welding purposes. Temperature in plasma arc can reach up to 17,000 degrees centigrade. It's a very huge temperature. Okay, this is mainly due to the constriction of the arc. Of course, the input power is highly concentrated to produce a plasma jet of a small diameter and very high power intensity. This is very, very important to understand. Suppose we are doing a welding, and suppose this is the one piece and this is the another piece. We want to join these two parts together. So what actually happens? This is the area we have to do the welding. If we are using a welding process, and the heat that we are taking through that welding process to melt these two plates where we have to do the welding, so what will be our requirement? Our requirement will be as much as we can constrict the heat area in this welding section. Okay, if heat will increase in this section, so what will happen? The most of the material of the base material will be affected by heat, and if it is affected by heat, what will happen? Coarse grain will be in that area. If coarse grain will be in that area, no need to tell, mechanical property will decrease. That we don't want. Okay. So what our requirement is, we'll try or we'll look for a process. If we are doing welding with that one, so wherever heat is required to join the two or more parts, that should be confined in that area only. So in this, it is very, very important to understand in this plasma welding what it has been written here: jet of a small diameter and very high power density. The jet, that plasma jet that will come out through the nozzle that we are using for the welding, these have a very small area. So what will happen, if we have to do welding in this area, so it is going to put heat in this area only. It will not be spread so that it will affect the other part of the workpiece also. It is very, very important. So that is the reason this process is used for very precise welding. Okay, now wherever we have to do, suppose in a circuit we have to weld a small part over there. So these kind of processes are being used because its intensity is concentrated in a very narrow area. So if it will be narrow area, it is not going to affect the other part of the workpiece. Okay, this process can be used to weld almost any material, including tungsten. That is another advantage and beauty of this process. It can be used for any material. It doesn't matter what the material is. Okay, na? Next welding process in this one is the thermite welding. This is also a very, very important welding process, and everybody knows it is used for welding generally of railway tracks. Okay. So what actually happens in this one? We have already seen at the starting one process, that was gas welding, where actually exothermic reactions were there between the C2H2 acetylene and oxygen. And whatever heat was being produced because of the combustion, we were using that heat to weld two materials. Here also there will be reaction between the thermite. Actually, this is known as thermite or thermite. It is actually a mixture of aluminum powder and iron oxide. So what will happen? These two will react and then heat will be produced. That heat will use to melt the material wherever we want to do the welding, and then we'll complete the welding. So this is a term very, very important that should be there in mind. What is the meaning of thermite? That is the reason name is thermite. Thermite means it is a mixture of aluminum powder and iron oxide that produces an exothermic reaction. Exothermic reaction means when there will be reaction between these two, heat will come out. Okay, na? It is not endothermic, means we have to supply the heat for the reaction to start. No. Once this reaction will be ignited and once these two will react, heat will be produced. That heat we are going to use to weld. In thermite welding, the heat for the joining is produced by superheated molten metal formed from the chemical reaction of the thermite. Okay, na? So whatever the heat is coming out because of the reaction that we are going to use to welding. So this is the reaction that actually happens, and through that we get the reaction. So what happens? Aluminium react with this iron oxide Fe3O4, and then the iron, and of course this aluminum oxide will form. But the most importantly, as this is a exothermic reaction, exothermic exothermic reaction, so the huge amount of heat will be produced, and that heat we use to weld the material. So what is its application? At this temperature, superheated molten iron plus aluminum oxide is made that floats on the top as a slag and protects the iron from the atmosphere. This is also very, very important. This slag that will be formed over there, it will float on the molten pool. Molten pool means if you are doing the welding, suppose this is the part and this is the part. So here this part will be melted along with, suppose we are using electrode. So this molten pool will be covered or shielded by the flux sorry, this slag formed because of this floats on the top as a slag and protects the iron from the atmosphere. So it will float on the surface or the weld pool and it will again shield it from the atmosphere. That's how welding will be completed. So in three steps, here it has been seen. Through diagram also we can see that this is the part we have to do the welding, and what we are doing, this super hot steel from the thermit reaction. Then it will come, and what will slowly it will come and fill this area. So this will be completely in liquid state. And once it will solidify, finally it will join. So we can see here. So what will happen? Whatever this slag is forming, it will float because of its low density. It will float on the molten section. Molten section means the weld pool where we are doing the welding. So once it will be on the top surface, it will not allow air to come and interact with this one, the inner part. So in that way, there will be shielding over there. In this process, there is no separate shielding arrangement. Means we are not using any gases. We are not using any extra flux over there. What is happened because of the reaction? Okay, this actually aluminum oxide is made that floats on the top. So this aluminum oxide itself will float and it will act as a slag over there and it will protect the iron to react from the environment. So in this lecture, we have already seen these three processes. Okay. Now we'll see what are the major application of this thermite welding. So as I said at the starting itself, it is generally used in railway lines for joining. And also the reason for this one is it's a portable arrangement. Means easily you can take this setup from one place to another place in nearby area, 100 kilometer range or 200 kilometer range. So easily you can take the setup from one place to another place. So easily it can be used for, that is the reason it is being used for the welding of the railway lines or railway tracks. Another is it is also used for repairing process, repairing purpose. Suppose two parts or two section we are using, and because of the wear and tear, some part has been wear out from one part. So this is also used to repairing for those ones. So repair of cracks in large steel castings and forgings like ingot molds, large diameter shafts, frames for machinery, etc. This is also used. So its major use is especially in construction where the large sections are and it has been wear out because of the use wherever we are using. So there also it can be used as a, for the repairing of that wear out parts, and of course it is used for the welding of the railway tracks. So we'll stop this lecture here and we'll continue with some other welding processes in next lecture. Thank you.